Welcome back. This is the second part of the tutorial for the Gyronimo Performance Pad R22 Beta 2. In the first part we went over the weight and balance page, performance page, and now let's have a look at the flight time page. Let's do a sample calculation. Let's say your intended true course is 80 degrees, something like this. And let's say your wind direction today is somewhere from 30 degrees in that area. And it's a strong wind today, so let's say you have 30 knots. Your airspeed might be around 80, and the variation at your place is, for instance, 10 degrees. This, by the way, is a typical Hawaiian setup. In the background you see Maui, and the variation there is 10 degrees. Variation means, by the way, whenever your magnetic North Pole is to the right of the true North Pole, then your variation is east. If your magnetic North Pole is to the left of the true North Pole, then your variation is to the west. Okay, let's stick with this. Now, in order to get a precise flight time, you also have to enter your pressure altitude. I assume for a helicopter 1,000 feet, the OAT is 15, and these numbers together calculate density altitude and a calibrated airspeed. And this calibrated airspeed is needed to calculate the true airspeed. So the calculated airspeed is calculated by, the calibrated airspeed is calculated by the figures from the POH, from the R22 manual. So with the true airspeed now, we go lower here in the next column, and the true course will be calculated, which is not calculated, I'm sorry, which is entered with our slider. Then in order to get a compass heading, we have to subtract or add the wind correction angle. In our case, it's minus 16. So if we change the wind direction, then the wind correction angle is 14 degrees. So let's go back to 30. Your true heading then is 64 degrees, and now we have to subtract or add the variation, and there's a lot of confusion about it. The easiest way to remember is east is least. So when you go from true to magnetic, you have to follow the rule east is least. So true course minus variation, and will give you a compass heading. Same with deviation. Let's say your compass deviation on that route is minus 7 east or 7 east, then you also would have to subtract that. Let's say we have the perfect compass and we don't have a deviation, so that I set this to 0. So now we have a compass heading, 54 degrees, ground speed is 58, and now we just enter a leg distance. Just click here so that you see the orange box, and let's say we have a leg distance of 120 nautical miles. So our flight time is 2 hours and 5 minutes. With this flight time, of course, we can go back to weight and balance and see if we can make it. Oops, no, we cannot. That's bad. So in that case, we know we cannot make this flight. So if our leg distance would be shorter, let's say 50, flight time would be 52 minutes, of course, we easily could do it. Now, of course, you can experiment with the wind direction and see how this affects your flight time. So let's say you have a really windy day, 35 knots something, and you have a strong a direct headwind, your flight time will be 1 hour 8 minutes. If you have a crosswind, your flight time is 41, and if you have a tailwind, which is nice, your flight time goes down to 26 minutes. Okay, so this is about this page. Let's go to the helicopter page now. Here, if you enter your email address, you can, by clicking on this button, you can send yourself an email with all the data from the weight and balance page. You can also switch to the video channel and see whether there are updates, or check our website for updates. Helicopter data gives you the data from the POH, in fact. So it's quite handy if you don't have a POH with you. You can use the figures from here. Same with the airspeed limits and other limitations like power plant limitations. So those values are directly from the POH. And last but not least, there's the definition table. So because there are a lot of abbreviations, I thought I put some of them in here. Okay, so that's about it. The nice thing maybe is the interaction between the weight and balance, performance, and flight time page. So the weight and balance itself is useless if you don't know your flight time. In order to make a correct performance calculation, of course, you need to do your weight and balance first. So I would go always from left to right, weight and balance, then performance, then flight time. All right. Yeah, one last thing. There is also coming up a iPhone version. So here's a sneak preview, because many people said, yeah, it's nice to have it, but the iPad is sometimes too large. So I'm trying to convert this down to the iPhone. It's tricky, but I hope to be able to implement the same functionality using the sliders, because I really like to work with those sliders now. All right, that's about it. I see next tutorial will be a practical sample application or a sample problem using the weight and balance and performance page. Thanks for watching. Bye.